In this video, we're going to look at conditional probability. And specifically, we're going to look at applying the multiplication and addition principles of probability. So our question of what's the probability of drawing an even number or a face card from a standard deck of cards. So we're looking at two different events. I'm going to define those events. Event A is drawing an even card. Event B is drawing a face card. So the first thing I need to do is I need to figure out what's the probability of each of those events separately, and then also what's the probability of event B given that event A has occurred. So event A, the probability is 20 out of 52 because there are 20 even cards in a deck of 52 cards. Event B is 12 out of 52 because there are 12 face cards in a deck of 52. And then the probability of B given that A has occurred is 0. Because even though you choose an even card, there's no way that any of those even cards is also a face card. So that's what we're looking for there. When we say the probability of B, given that A has occurred, is we're asking for, knowing that it's already an even card, what's the probability that it's also a face card, which is 0. So once I have those three probabilities worked out, then I'm ready to apply the multiplication and addition principles. So the multiplication principle says the probability of A and B occurring at the same time is equal to the probability of A occurring multiplied by the probability of B given that A has occurred. And then the probability of A or B, which is what our question is actually asking, is equal to the probability of A plus the probability of B minus the probability of A and B at the same time. So since I've already done each of those individual probabilities, A, B, and B given A, all I really have to do is just plug some things in. So I have to plug into the first equation to determine what's the probability of A and B, and then I can take that answer and plug that into the second equation. So the probability of A and B, which is probability of A, which is 20 out of 52, multiplied by probability of B given A, which is 0, and of course anything times 0 equals 0. So the probability of drawing a card that is both an even card and a face card, which makes sense, is 0. So then we get to the question of what's the probability of drawing a card that is either even or a face card. So the probability of drawing an even card is 20 out of 52. The probability of drawing a face card is 12 out of 52. And the probability of drawing a card that's both is 0. So we add the probability of each individually and subtract out the probability of the two occurring at the same time, which is that intersection. So 20 plus 12 is 32 out of 52 minus 0, and we simplify 32 out of 52 to get 8/13. The one thing that I do want to mention about this is the relationship between these probabilities and the mutually exclusive and independent events. One way to tell if two events are mutually exclusive is if the probability of A and B equals 0. So when we work out the probabilities there for A and B, we get 0, so we know that an even card and a face card are mutually exclusive. Now in this example that's pretty obvious, but not always is that the case. When we talk about independent, the rule for knowing whether two probabilities are independent is if the probability of A multiplied by the probability of B given A is the same thing as the probability of B by itself. So those are our multiplication and addition principles applied to probability.